Hi there, my name is Gavin Purell. I'm going to create a adding fractions video, so hopefully it'll help you guys out if you're having issues adding fractions. So to get started, we're going to go over a few different things. So for this video to be the most helpful for everyone, a small understanding of what fractions are and a little bit of how they work would be excellent for this video to help you out. But if not, I'm going to have a quick little overview of what fractions are and what numerators and denominators are and what to do with them to add them. So other videos will go over subtracting, multiplying, dividing, and mixed fractions. So if you need help with adding, this is your video. For a quick recap, we're going to remember fractions aren't whole numbers. So 1 over 2 is a fraction for 1/2. So if we're going to look at that in a picture aspect, there's a circle, and then let's half it right there. Imagine that's a perfectly straight line, and then half this circle is going to be colored in. So half this circle is colored in. Another aspect is 3 over 4. It's another fraction. So let's look at this in representation to a circle. So here's our circle. Then we're going to perfectly draw my lines in again. There we go. And then so 3 out of the 4 are going to be colored. So this one's going to be colored, and then this one will be colored. So the 3 out of the 4 are going to be colored. So that's kind of what leaves our fraction. If all of them were colored, it'd be 4 out of 4. So now let's look at the number aspects of our fractions. So let me just clean the screen for all of you. So then let's go back to my pen. So let's look at 6 over 7. So the top number, that's going to be circled in red, is our numerator. I'll type that in. So numerator. And then our bottom number here, the 7, which will be circled in orange, was our denominator. There we go. And I'll type that up on the screen there. So our numerator represents how many parts, or how many number of parts there are in the fraction. And the bottom number, the denominator, tells us how many parts it's divided into. So there's potentially 6 out of the 7 are going to be colored in. The numerator basically tells us how many of the total number are going to be colored in our circle. So if I'm going to draw the circle in there, make it black. Now let's break it down into 7 parts, best I can. So 1, so basically, let's see, 1, 2, 3, 4, 5, 6 out of the 7 are going to be colored in for our fraction. So I'll clear the screen for everyone, and then let's go look at adding fractions today. To start, we'll start with the fraction 3 over 5 plus 1 over 5. So when we're adding fractions, first thing we're going to do is we're going to look at the denominators. And if the denominators are the same, we're going to know it's going to be an easier question than other adding fraction questions. So the first thing we're going to do is we know that the denominators are 5 in the first fraction and in the second fraction. So we know that in our answer, the denominator is also going to be 5. So if you look 5 there, there, and there. So the adding part comes in is when we're going to start looking at the numerators. So we're looking at the tops of the fractions. So when we're adding, we're going to add the 3 and the 1. So we're going to get 4 out of 5. So that's going to be our fraction. And we're going to use our circle diagram to look at our fraction. That's a little bit of an oval, but so this is broken down into 5 parts. So that's 5 equal parts in your imagination. So we start off, we have 3 of the 5 are going to be all colored in. So this represents our first fraction right here. And then we're going to add 1 over 5. So we're going to color in one part of our total fraction because they have the same denominators. So we'll color that in, and then now our final product here depicts our final fraction answer. So there we go for that. So that's a pretty simple adding equation there. So I'm going to introduce what happens when we don't have the same denominator. So I'll clear the screen for everyone. And now I'm going to talk about something called a common denominator. So a common denominator is something that we have to find whenever our fractions don't have the same denominator. So let's use a really, really easy example of 1 over 2 and 1 over 3. So 1 over 3. So if we look here, the denominators are not the same. So now we have to go find something called a common denominator. The common denominator is going to be a factor that both the 2 and the 3 are going to go into. So to find this, what we're going to do, I'm going to do my work in red. So we have basically what you can do. So you look at this fraction here, and we're going to multiply the top and bottom by 2. Because you do that to the top, you do it to the bottom of the fraction. You're not actually changing. You're changing the appearance of the fraction, but it's still going to mean the same thing. It still represents the same proportion. So if you do the top, so 1 times 2 is 2, and then you look at the denominator now, the 3 times the 2 is going to be a 6. So therefore, you've changed the appearance of the fraction, but it still has the same representation. And now I'm going to change the next part. So we do the 1 over 2, I'm just writing it here down here in orange, and we're going to multiply by this denominator right here. So top by 3, the bottom by 3. That's going to equal. So the 1 times the 3 is the 3 over, and then you look at the denominator, 2 times 3 is 6. So this is the easiest way to get this denominator same for both the fractions if you multiply by the opposite denominator. So now you have the fractions, and if you wanted to add the two, I'll do it in black. What we would do is we would do the 2 over 6 from our first work in the red, and then we're going to add it to the second work in the orange, plus the 3 over 6. And hey, what do you know? So our denominators are now the same, so we know that the denominators are going to be the same in the final answer, and then now you just need to add the top. So the 2 plus the 3 is going to be the 5. Our circle diagram won't necessarily work very well when we don't have the same denominators. You'll have to learn something called equivalent fractions, which I'll probably cover in another video if I decide to make another one. It's a little bit trickier to overlap and color in another part of your circle or fraction because the denominators are broken down into different parts. So let's do another example that's going to be a little bit trickier than this one, maybe a little bit. So clear it. So let's go with 2 over 7 plus 1 over 2, 1/2. So what we're going to do here is we look, our denominators are not the same. So I'll use my other color red here. So what we're going to do to this first fraction here is we're going to multiply it by the denominator of the other fraction. So times the top by 2 and the bottom by 2. Remember, we're just changing the appearance of the fraction. We're not changing what it means or represents. We're just changing the appearance of it. So I'll do my work down here for it. So the 2 times 2 is going to be 4. And then the 2 times 7 is going to be 14. So our new fraction for this one right here is 4 over 14. Now in my work in orange, we're going to look at our second fraction right here. So our second fraction, we're going to multiply by the denominator from the first one, so the 7. So we're going to multiply the top and the bottom by 7, changing the appearance of it. Multiply that by 7, multiply that by 7. So let's go plus. So 1 times 7 is 7, and then it's going to be over 2 times 7, it's going to be 14. So if we look now here in our new equation down here, our fractions are 4 over 14 plus 7 over 14. So our denominators are now the same. So equals, so denominators are the same. We know in their final answer, the denominators will be the same. So 14. And then we look at the numerator, so we add the 4 plus the 7, that's going to be 11. There we go. That's my little intro into adding fractions. So for a bonus hint that I'm going to give everyone, if we have fractions with the same denominators, let's go 1 over 5 plus 2 over 5, you can rewrite this. It's going to be the same as if you write it as 2 plus 1 over 5. So yeah, so those are equivalent. So that's a fun little hint if you guys need. It's a little bit extra, and yeah, just throwing it out there for everyone. There you go. This is the rest of my video.